Okay, so as what I have said, let us now have an example of the integration of combined functions of sine and cosine. So let's say we have need to integrate or evaluate, say we have sine cube x d of x. Okay, if we have this similar like this, we can retain one power of sine here, so that it will serve as the derivative of the cosine here, and we will convert the rest in terms of cosine using the trigonometric identity. Say we can also write this as sine squared x times sine of x. dx. Okay, we just retain one power of sine here. Then later on we will use this identity so that the rest can be served as the derivative of this cosine. Okay, so say what type are we gonna use? So we have sine raised to some function. I mean sine raised to some integer. Okay, so according to this, we have this identity sine squared u. So let us try to use this identity first. We have sine squared u is just equal to 1 minus cosine squared x times sine of x dx. Okay, so let's say this sine squared x here is just equal to this identity 1 minus cosine squared x. Okay, then just copy the remaining functions in our integrand, which is sine x dx. Okay, so right after that we can further simplify this by distributing sine x dx in our function here. So 1 times sine x dx, so we have sine x dx, then minus the integral of cosine squared x sine x d of x. Okay, then we can now proceed to the integration. So for this one, we can now simply integrate this because we have the integration of this trigonometric function. We have the integral of this function. So the integral of sine x dx is just negative cosine x plus c. Then let us further integrate this. So let me rewrite this as sine x dx. Okay, as you noticed, since we already did the integration in this part, we don't need to write the integral sign, because this is now our integral. Okay, so no need to write the integral sign. But on this side, um, we are not done yet with the integration. That's why we retain the integral sign for this function. So if we have a combined functions like this, cosine and sine, so let us now determine which type it is. So we have the positive and odd integer, then the our n here is 2, and our m here is positive 1. So this is under type 1. And then as you noticed here, the derivative of cosine is just the sine x dx here. So let us use the change of variable. So let u is equal to cosine x. By the way, before we proceed, let us review our algebra, or I mean our trigonometry regarding this. So if we saw something like this, it only means that it is equal to this form. Okay, so this cosine square x here is just equal to cosine x raised to 2. Then we have sine x d of x. Okay, so if we have something like this, as you can see, this is raised with some power, and as you can notice, the derivative of cosine is just sine x dx. So our technique is just we let some variable u is equal to cosine x, then the derivative of this is just the derivative of cosine is negative sine x dx. Okay, and then after this, then we can now substitute back, or we can now change the variable from x to u. So in here, this is our u, the cosine x, and then this term here is our sine x dx, which is equal to du all over negative 1, or negative du, or negative du is equal to sine x d of x. So from here, let us simplify. Let me copy first. We have cosine x squared sine x dx. So we say that this term here is just equal to u, but it is raised to 2, and then this term here, sine x dx, is just equal to negative du negative du. Okay, so do not forget to write the the answer or function or forms before our integral sign. So let me copy our final answer. Okay, so from here, notice we can easily integrate this using power formula. So we have negative cosine x, negative times negative is just positive, u, 2 plus 1 is just 3 all over 3 plus c. So finally, our answer is just negative cosine x plus, what's the value of u? We have cosine x raised to 3 all over 3 plus c. Or simply, we can write this in a form like this one. We have 1/3 cosine 3x plus c. Okay. Now, this is our final answer. We have negative cosine x plus 1/3 cosine 3x plus c. Cosine raised to 3 x plus c. Okay, so once again, if we have a problem like this, then we can retain one power of sine. We can retain one power of sine to serve as the derivative of the derivative of the cosine, and convert the rest in terms of the identity, which is sine squared x is just equal to 1 minus cosine squared x. Then the remaining sine squared x dx here is this. Then finally, we can now distribute sine x dx to this whole term here, and we saw that after the distribution, we find that the integral of sine x dx is just negative cosine x, and the integral of this negative cosine x squared x sine x dx here is just or can be find using the change of variables, wherein we let u equal to cosine x, because we notice something that if we let this as u, this whole term here is just the cosine of this one. So we let this as equal to cosine u. So after that, we got the derivative of u, which is du is equal to negative cosine x dx. And then we we convert all x terms using the equivalent u and derivative of u, so we come up with this. So we have u squared minus du multiplied by negative du, and then after simplifying, we notice that we can use power formula, which is u to the 3 all over 3, then plus c. Then after that, we bring back the value of u, which is cosine x, then but it is raised to 3, and we can rewrite this as the as similar to this, cosine raised to 3x plus c. Therefore, our final answer is negative cosine x plus this term plus c. So that is the integral of this sine cube x d of x.